In this video, I'll be covering one of the key computational thinking concepts, which is abstraction. I want to start off with the definition of abstraction. Abstraction is the process of removing unnecessary detail from a problem and keeping only the relevant information. It focuses on what's important to complete or solve a problem. In computer science, there are thousands of examples of abstraction. It is used continually by programmers. Now, let's consider this map I've got here. So you can see that this map has quite a lot of information on it. So you can see that you can see the trees, it's an aerial view, you can see the roads, you can even see the islands on there, and you can even see the labels of the different places that are around there. Now obviously I am looking for public transport. So obviously public transport is on there, but it's actually very difficult to see, and there's a lot of unnecessary information for what I'm trying to identify. So what I could do is simplify that further. So here on the left hand side, look, I've got rid of all of the physical attributes such as of the trees and the buildings and the roads, and now it's just giving me like an overview of all of the transport throughout of London. And you can see, look, on here, look, it's still got, I'm after particularly the train route. Okay, so here there is a train route, but I can't really see it because I need to abstract information further. I need to remove the unnecessary information. So the information that I want is there, okay, but along with other stuff that I don't want. So I remove that further, and now look, I end up with, you can see, look, these parts are still the same, but I've just highlighted the information that I want, okay? It's far less detail, okay? By doing this, it means that I'm able to solve the problem quite quicker, okay? It's easier, it makes my job easier to identify what I'm after. So, if we go forward again, and we take a deeper look into abstraction. Abstraction is taking place all of the time, especially when we are programming. When a programmer is programming in a high-level language such as Python or C#, they don't consider what is happening in the background, okay? And why would they? Because it's not particularly relevant to what they're doing. They're making a program, for example, a program that might check someone's age for purchasing a game or a lottery ticket maybe. Why would they consider the very, very, very low level aspects that are happening? So if I take this example here, look, right down to the nitty gritty of computing is transistors. So transistors basically turn on and off, and that is basically the voltage of the computer, and that is basically how the data is read at its lowest form. Okay, if we were to abstract that and go further up, we don't need to know that, so we go further up, and then we get to machine code, which is basically binary, which is zeros and ones. Again, we could abstract that even further, and we'd come up to assembly language. And this is basically, it's a set of simple instructions that the CPU would use to complete a task or solve a problem. But again, if we were to abstract that further and we would apply a high level language, well therefore we've got things like built-in libraries, built-in functions and procedures that we can use that make programming a lot easier. So obviously the abstraction here is that we've got rid of all the unnecessary information that we don't necessarily need to know about. Obviously they might happen in the background, but we don't need to know about them in order to go and make a program in one of our lessons. So that is one of the types of abstraction that happen all of the time. Moving forward again. So abstraction happens in lots of different ways. So for example, I hope you are familiar with a GUI. If you don't know what a GUI is, it's a graphical user interface. Your phone has one. Your computer has one, and most devices that you use will have one, to be honest. So on the screen here I've got a number of buttons or logos or icons, whatever you want to call them. Okay, I'd probably go with icons personally. Notice that they've got no text on there, but if you look at this here, without me saying it, what do you think that is? You're going to say it's a play button. So it doesn't need the text because it's unnecessary information. The icon gives us all of the information that we need, so we can abstract the information that's not necessarily important or necessary. If we look at this one, you would say that it's a volume button. You'd say this one's a microphone, set of headphones, a power plug, okay, a clock. Again, we don't need them to write down what that icon's for because the picture tells us. So we've abstracted the unnecessary information of, for example, the wording that would go underneath and would take up some room. So, abstraction. Let's take a look at an example that might be very similar to something you might get in your exam. So I've wrote here an example. This one is going to look at a scenario. Now all I want you to do is apply abstraction as we go through and see if you can remove anything that isn't necessarily important and not needed to solve this problem. So I'm going to read you the problem first. Many of my clients ask me to clean their cars for them. All of these clients pay me to do this, and the amount I get paid depends upon how long it takes to clean the car. I like to clean the car in the morning when the weather is normally best, because I often get hot, so I take my jumper off while cleaning the cars. I need you to help me keep track of how much I'm owed. Fortunately for me, all of my clients have different last names, so it is easy to tell them apart. After I finish cleaning the car, I like to go to the park and walk my dog to relax. I charge £15 for 30 minutes of cleaning, and I always round up. So for example, if it was 48 minutes, I would round up to 2 half hours and charge £30. So there's the scenario. So what you might want to do here is just pause for a second, okay? See if you can spot anything that's blatantly obvious that isn't needed and remove. So we're going to step through it again, okay? Have a read of it, and I'm going to pop the first one on the screen now. So you'll see, here look, I like to clean the cars in the morning when the weather is normally hot. I take off my jumper when cleaning the cars. Obviously that can go, it's not important, is it? Okay, that's not going to affect the creation of the program, is it? So the way I like to look at this is, quite often when you get given a problem, you'll be told it by a customer or a client, and quite often they will have conversations with you, just a general conversation, and in between they'll pause and go, oh, on the weekend I did blah 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 blah. That's pretty much what this is mimicking. So straight away we've got rid of that. Have a look, there's definitely another one on there. So if you have a look again, pause if you want to. We've got this one. After I finish cleaning the cars, I like to go to the park and walk my dog to relax. So straight away, both of those have no level of importance into solving this problem. So I have crossed them out and I've removed them. So if I was then going to tackle this program, okay, I would then break it down into steps. Can you guess the really important steps that I've taken, okay, or I've kept? Because I've extracted the information that's not necessary and got rid of it. So what key facts am I going to keep? I get paid depending on how long I take to clean the car. All of my clients have different last names. That's important because I'm able to tell the difference between them. Charge £15 for every 30 minutes of cleaning, so I can now work out how much they owe me. I always round up, so if it was 48 minutes, I would be charging for two 30-minute sessions, therefore I'd charge £30. So what might happen now is you've extracted the information, and you might be asked to create an algorithm in the form of a flowchart or some pseudocode surrounding this. So effectively, you've applied computational thinking, you've extracted the important information, and now you are able to use it. You would then start using decomposition and breaking this down into steps to solve your problem. So let's just do a quick recap. Abstraction is the process of removing unnecessary detail from a problem and keeping only relevant information. Okay, the key advantage of abstraction simplifies the problem. It removes all unnecessary information that is not needed, making it easier to solve the overall problem and see the direct thing that we're being asked to do. That's pretty much it for this video, so thank you for watching. I hope you enjoyed that. If you've got any questions, please feel free to contact me on this channel.